Welcome and thank you for your interest and time today. We are set to demonstrate CorVeras Gas Void Fraction Monitoring System, CorX, at a state-of-the-art process training unit in Houston, Texas. Our interest is in measuring gas void fraction that could potentially be found in any separator liquid outlet, which may have gas carry under or gas break out due to either upset conditions or inefficient separation. In this configuration, CorX is directly measuring the gas void fraction within the individual flow tubes of the Coriolis meter. It could equally be positioned across a turbine meter. CorX can be installed on a minimally intrusive basis, either as a retrofit to existing process piping or a new build piping. In the process training unit, there were no pipe tappings either side of the Coriolis meter under test. The CorX installation was accomplished using industry-standard bleed rings. These rings and sensors are installed between the process piping and Coriolis inlet and outlet flanges. Each bleed ring is equipped with dual sensing ports, allowing for the installation of instrumentation immediately upstream and downstream of the Coriolis meter. This ensures gas void fraction internal to the flow tubes is being measured at the flowing conditions within the meter. CorX is agnostic to Coriolis manufacturer, type, or size. Each bleed ring is instrumented with an acoustic pressure sensor and a static pressure sensor, enabling the CorX system to accurately measure the speed of naturally occurring sound of the process fluid within the flow tubes of the Coriolis meter. In a field installation, CorX would use existing static line pressure as an input, requiring only the addition of the acoustic pressure sensor. On this liquid-based loop, the gas, in this instance compressed air, is injected via the red instrumentation line ported into a third bleed ring installed upstream of a second Coriolis meter, not utilized for this demonstration. The rate of injected gas is measured by a reference micro Coriolis meter, while a mag meter provides a reference for the liquid phase. This setup allows for the air injection into the single-phase water flow, then passing through the first meter acting as a mixer, before the bubbly fluid enters the Coriolis meter under test. The CorX processing unit displays a graph that shows the reference injected gas volume fraction in red and the gas void fraction measured within the Coriolis meter reported in blue. Starting with a baseline of 0 entrained gas, at a fixed water volume, we progressively increase the volume of injected air. The chart is updating real-time, showing good agreement between reference injected gas volume fraction and measured gas void fraction. We continue to inject air. The graph stabilizes around 2%. CorX continues to show good correlation with the reference. It is important to note that we would not expect an exact correlation between the reference injected gas volume fraction and the gas void fraction measured by the CorX system. The injected gas volume fraction and the measured gas void fraction within the tubes can differ due to many effects. Examples are some of the injected air dissolving into the undersaturated water and slippage between the air and water phases. This demonstration was limited by the process training unit flow loop to an upper limit of approximately 5% gas void fraction. Throughout this demonstration, spanning 0 to 5% gas void fraction, the correlation between the measured and reference data clearly demonstrates CorX precision and fidelity in measuring gas void fraction real-time. The demonstration was run over several days with multiple test points with low and high liquid flow rates, repeating the cycle of gas injection. CorX continued to provide a close correlation of measured and injected GVF, independent of liquid volumetric rates, across all test points. There is a separate report, available on request. For end users, CorX not only offers the precise quantification of the gas void fraction, but enables correction of measurement errors, mass flow, density, and volumetric flow that may be associated with the presence of entrained gas. CorVeras CorX Gas Void Fraction Measurement System offers a practical, minimally intrusive, real-time solution to the long-standing challenge of quantifying gas void fraction in bubbly liquids. If you want to learn more about CorX and where CorVera is adding value to industrial process measurement, visit us at www.corvera.il. Thank you for your time and interest today.